Hello students, today also we are going to learn some basic sums of integration. Evaluate question number 1, integration of tan square x dx. Now if you check the formulas of integration, then there is no direct formula is given for tan square x. So first we will apply the trigonometric function for tan square x. That means we will write tan square x in terms of sec square x. So we know the formula that tan square x is nothing but sec square x minus 1. So here we will write integration of sec square x minus 1. Since two terms are present, we will write integration two times. So integration of sec square x is tan x. Now we know the direct formula, and integration of 1 is x plus c, constant of integration. Question number 2, integration of sin 2x upon cos x dx. Now here also first we will write the formula for sin 2x, and we know the half angle formula. Sin 2x we can write as 2 sin x into cos x. So substituting that formula here, we will get integration of 2 sin x into cos x upon cos x dx. Now cos x gets cancelled. So integration of 2 sin x dx. This is the simplified form of given question. Now this 2, which is constant, or we can say coefficient of sin x, that will be as it is, and integration of sin x is minus cos x plus c, that is constant of integration. So this is nothing but the integration of given question. Now question number 3, integration of cos 2x upon sin square x dx. Now we know that there are 4 formulas are for cos 2x. Out of that 4 formulas, we will use any one of the formula. Suppose we use cos 2x is equal to cos square x minus sin square x. So by writing that formula here, we will get cos square x minus sin square x upon sin square x dx. Now since sin square x is common denominator for both the terms, so here we will write cos square x upon sin square x minus sin square x upon sin square x dx. Means that common denominator we can write for both the terms. Now we know that cos upon sin is cot. So cos square x upon sin square x is nothing but cot square x. And for the second term, sin square x gets cancelled. So here we will get 1. Now before applying the integration, first we will recall the formula. Is there direct formula available for cot square x? No. So again, just like tan square x, here also we need to write this cot square x in terms of cosec square x. So we will write cot square x as cosec square x minus 1, and this minus 1 which is already present. So cosec square x minus 2 will be the simplified form of the given term. Now we will write integration for both the term. Then integration of cosec square x is nothing but minus cot x minus integration of 2 is 2x and plus c, that is the constant of integration. Now in question number 4, integration of sin x upon 1 plus sin x dx. Now here, since we cannot apply any of the trigonometric formula, so we can simplify this by taking conjugates, by multiplying numerator and denominator by the conjugate of denominator. So denominator term is 1 plus sin x, conjugate of that will be 1 minus sin x. So here we will multiply and divide by that conjugate. Now if you check the denominator, then it is in the form of a plus b, a minus b. And we know that a plus b, a minus b is nothing but a square minus b square. So here we will get 1 square minus sin x the whole square. That means 1 minus sin square x. And numerator will be sin x into 1 minus sin x. Now as sin square x plus cos square x is 1. So 1 minus sin square x is nothing but cos square x. So that formula we will apply, and in denominator we will write cos square x. Now in numerator we will multiply this bracket by this sin x which is given outside. So sin x minus sin square x upon cos square x dx. Now here also, since common denominator is present, we can write the same denominator for both the terms. So we will get sin x upon cos square x minus sin square x upon cos square x dx. Now when we will simplify this, since here two cos terms are present in the denominator, one cos term we will write for sin, that is sin upon cos, and one cos term will be as it is, that is 1 upon cos. So 1 upon cos x is nothing but sec x, and sin x upon cos x is nothing but tan x. So this term is nothing but sec x into tan x. And here, since we know that sin x upon cos x is tan x, so sin square x upon cos square x is nothing but tan square x. So since two terms are present, we will write integration sign 2 times. Now integration of sec x into tan x dx minus integration of tan square x dx. Now integration of sec x into tan x is nothing but sec x. We know the formula. But since no direct formula is available for tan square x, just like question number 1, here we will write tan square x in terms of sec square x, that is sec square x minus 1. But since minus sign is present in the middle, the sign of this 1 will get changed, that will become plus. So integration of sec square x dx is nothing but tan x. Integration of 1 is x. So total answer is sec x minus tan x plus c, that is constant of integration. Now next, question number 5, integration of under root 1 minus sin 2x dx. Now here also, instead of sin 2x, we can write the half angle formula, that is 2 sin x into cos x. But by writing that formula, we cannot simplify further. So at the place of 1 also, we will write the formula. We know the identity that sin square x plus cos square x is 1. So that identity we can write here. So the terms will be sin square x plus cos square x plus 2 sin x into cos x. Now if you observe this term carefully, then this is in the form of a square plus 2ab plus b square, where we can say that sin x is nothing but a and cos x is nothing but b. So in under root we can write sin x plus cos x the bracket square dx, because if we split this bracket, then we will get the same expansion. Now square root and square gets cancelled, and therefore we have integration of sin x plus cos x dx. So integration of sin x dx plus integration of cos x dx. Now integration of sin x is minus cos x, and integration of cos x is sin x plus c, that is constant of integration. Now question number 6, integration of 2 upon under root x minus under root x plus 3 dx. Now since root terms are present in the denominator, here by looking at the question, it is very clear that we need to rationalize the given term. So we will rationalize this by taking conjugate of denominator. So conjugate of denominator will be root x plus 3. So multiply and dividing by that term, in denominator we will get, in denominator we have the terms in the form of a minus b, a plus b. So in denominator we will get a square minus b square. So under root x square minus under root under root x plus 3 the whole square, and numerator will be 2 into bracket root x plus 3. Now in denominator square root and square will get cancelled. So we will get x minus in second bracket x plus 3. Now if we open the bracket, the sign of this term will get changed. So we will get x minus 3. So x gets cancelled, we will get only minus 3. So this 2 and this minus 3 we can write outside, that is minus 2 by 3. Now integration of root x plus integration of root x plus 3 dx. Since two terms are present, we will write the integration sign 2 times. Now root is nothing but raised to half. So integration of x raised to half dx plus integration of x plus 3 raised to half dx. Now by using the formula of x raised to n, we will get x raised to n plus 1 upon n plus 1. So here x raised to 3 by 2 upon 3 by 2 plus x plus 3 raised to 3 by 2 upon 3 by 2 plus constant of integration, that is c. Now since here linear function is present but coefficient of x is 1, so here no term we will write in the denominator to multiply by 3 by 2. Now this 3 by 2 which is here in the denominator, that we can take common, and since that 3 by 2 is there in the denominator, when we will write in the numerator, that will become 2 by 3. So minus 2 by 3 into 2 by 3, that is minus 4 by 9, and the remaining term will be as it is. Thank you students.